Okay, so we're now on problem number 4, and I chose this problem because we can't factor, we don't have any sine squares, we can't really use any formulas. However, if we square both sides of this equation, we might be able to find something. So, and this might not be the only way to do it. We're just, I'm just trying it. But also keep in mind, anytime you square each side of an equation, you could end up with extraneous solutions. You might get something that looks like it works, but it doesn't. So that's what happens here. So I end up having sine squared equals. Now I have to this is 2 plus root 3 cosine of x times root 3 plus, 2 plus root 3. Oh my gosh, it looks like this. I cannot speak today. So you are going to have to multiply those two binomials. You know what I mean by that? FOIL? Okay, so that equals 4 plus 4 root 3 cosine of x plus 3 cosine squared of x. There we go. Because root 3 times root 3 is 3. That's where that comes from. Now, I'm going to go ahead and I've got a cosine and I've got a cosine squared. I'm going to choose to substitute in 1 minus cosine squared for the sine squared, so that I've got all sines and cosine squareds, and then hopefully I'll end up, when I throw everything to one side, I'll hopefully end up with a trinomial that I can factor. I don't know if it's going to work or not, but so that'll be 1 minus cosine squared of x equals 4 plus 4 root 3 cosine of x plus 3 cosine squared of x. Okay, now I'm just going to throw everything to the same side. So if I've got a 3 cosine squared and I subtract that over here, and I've got a 1 cosine squared, I'll have a total of minus 4 cosine squareds. Bless you. So I have minus 4 cosine squareds of x minus 4 root 3 cosine of x minus 3. Just threw everything to the same side. Now when I factor, I usually like to take out a negative, so I'll go ahead and do that. Each of these terms are negative, so I'm just going to pull a negative out. And then when I factor it, it's a perfect square trinomial. This ends up being 2 cosine of x plus 1. No, plus root 3. Root 3, 2 cosine of x plus root 3. We've got 4 cosine of x, 2 root 3 plus 2 root 3 for a total of 4. Root 3 plus root 3, 3. Equals 0. Any questions up until here? I kind of skipped some steps, so you might have questions about where the negative went or anything like that.
You factored it out, right?
I did. So I first pulled the negative out, so this became 4 cosine squared of x plus 4 root 3 cosine of x plus 3 equals 0, and then I factored it. So now really all we have to do is set one of these equal to 0 because they're both the same. So when you do that, you get 2 cosine of x equals negative root 3. I'm in the way here. And then divide by 2. So you'll get the cosine in blue. The cosine of x equals negative root 3 over 2. And negative, cosine is x, and that's negative left direction for x. So I have got 5 pi over 6 plus 2 pi k and 7 pi over 6, which is the extraneous solution. And the reason you know this is whenever you square both sides, you got to check both solutions. If I plug in 7 pi over 6 into the original equation, not the squared equation, okay? Here's my check. This is back from Algebra 1 when you do a check. Sine of 7 pi over 6 should be equal to 2 plus root 3 cosine 7 pi over 6, right? If it works. But what happens is the sine of 7 pi over 6 ends up being a negative 1/2. And then we end up here with negative root 3 over 2 times root 3. That becomes a 3. 2 minus 3 halves. We end up getting negative 1/2 equals 1/2. And that doesn't work. So this is an extraneous solution. So this is the only solution. So basically, check your solutions and make sure they work. Plug them back in. You go back to the original, you take the solution, you go back to the original equation, and you plug it in for x. And make sure that both sides equal each other. If they don't, then it's an extraneous solution.